So technology, right, is oftentimes inspired by nature, right? So it asks here, how can new technology be inspired by nature? It says here, no matter what you want to do with a machine or process, there is a good chance that there is an organism that does it naturally. So for example, let's suppose you want to build a plane. Well, we already have, bats and butterflies and flies and birds and all kinds of things that also fly. So if you want to build an airplane, one thing that you can do is you can look for inspiration. You can look to birds and other kinds of organisms for inspiration and get some ideas that can help you to do what you want to do, right? So for example, it says here, do you need an aircraft that can hover and fly backwards? The hummingbird already does that. So we could maybe look at the hummingbird and study, okay, how does the hummingbird hover in one place? We can study it and then we can make something that's similar, right? It says here moles, right? Moles are those tiny like mammals that live in the ground. They are experts at making tunnels, right? So we can kind of figure out, okay, how does a mole make a tunnel? And we can make something that's similar to that. So this idea is called biomimicry. Remember we talked about this word at the beginning, bio meaning life, and mimicry meaning that we're trying to copy something. So biomimicry is the imitation of living organisms. So over here on the right, we have one example, right? We have the spider. And of course, the spider makes a web, and this is called spider silk, right? It's not the same thing as the silk that comes from the silkworm, but it's kind of similar kind of thing. So this is basically a very, very strong kind of material. In fact, they say that compared to its weight, that this spider silk is actually stronger than steel, all right? So if we take so much of this spider silk and put it together to make the same amount that we the same amount of stuff that we might use to make like a steel bar, this would actually be stronger than the steel bar. This is giving us another example. If you take a look at shark skin has this type of scaling system, right? It has these types of scales, and that helps the shark to remain aerodynamic underwater. And so people have learned from shark skin, and they make swimsuit fabric that kind of has a similar microscopic detailing as shark skin. So again, this is biomimicry. We're learning from the shark skin, and so we're trying to mimic it. Here are some other examples. Again, like an airplane, the wings could be similar. We could learn from the wing of like an albatross or of a shark, the fin of a shark, and we could try and make something similar to it, and that's going to help us to either go underwater or fly in the air. Now, this is also an example of biomimicry. So over here on the left, right, we have a bone, right? This is the bone of a bird. You notice that inside the bone of a bird, there's all of these different holes, right? So why is this so empty? Why is this bone not solid? Well, it has to be empty because the bird has to be light enough in order to fly. So their bones are basically hollow. And so they look like this. Inside, they just have like thin segments that connect the two parts of the bone together so that most of it can remain empty and hollow so it doesn't weigh too much. So this idea, people have studied this and looked at this, and they have used this to make lightweight buildings. So this building over here, the structure inside is, kind of the same as the structure of a bird bone. So again, it's mostly hollow. So that means it requires less material, it costs less, and it's not going to be as heavy.